we are going to learn a couple more ways to evaluate limits. So you'll want to watch carefully because this is going to be kind of brand new stuff here that we're doing in part 2, still limits, but we'll run into some other problems when we go to find them. What I put up here first, before the examples, is I put basically a couple descriptions of what kind of methods we're going to be using today. This would be pretty helpful to have in your notes so when you look back later you remember how we did it. It's just titled Other Methods to Evaluate a Limit. And I put in parentheses there that this is what you want to try if direct substitution doesn't work and if factoring doesn't work. If you can't do either of those things, then that kind of leads us into our next couple of methods. Alrighty. Now for the first one, I'm going to refer to this method as rationalizing radicals. It says rationalize radicals. And this is basically just how you get started. It's not the entire method. I'm just trying to give you some key ideas. To rationalize radicals, you want to start by multiplying by the conjugate on top and bottom. Again, it's not going to make a whole lot of sense right now because this is just the first step. There will be more that you have to do after that. But I'm trying to give you some key ideas so when you look back at your notes later, you remember how you at least got started. To rationalize radicals, meaning roots, there's some kind of root in your function. You want to start by multiplying by the conjugate on top and bottom. So it'll be a fraction or a rational type of function. Now the other method that we're going to run into today is simplifying. Hello there, come on in. Okay, that is fine. This is the second part of section 1.3 if you want to jump in with us. The other method that we'll be doing today is simplifying complex fractions. And again, this is just kind of the first step. Multiply by the LCD. Do you remember what that stands for? Oh boy, been a while. Least common denominator. Multiply by the least common denominator of the fractions on top and bottom. So again, right now you're putting this in your notes. You're not really sure what all of this means. That's totally fine. Once we get started, these little steps here will help us get started. So if you try direct substitution, it doesn't work. You try to factor, can't be factored, then look to see if you have radicals, try to rationalize them. If you have complex fractions, which by the way, complex fraction means there's fractions in a fraction. Okay, they're complex. You got a lot of fractions going on. If that's the case, try to simplify those by multiplying by the LCD on top and bottom. All right, so our directions today, I'm just going to put them up here with all this other stuff. Directions are still to find the limit. You aren't going to run into any today that do not exist, so I'm not going to put if it exists, because I think they all do. Find the limit. Okay, here's number 1. You got to be on your game today because this is tricky stuff here. Getting into some good material. We're finding the limit as x approaches 3 of the square root of x plus 6 minus 3 all over x minus 3. Okie doke. Well, first thing to do in any limit problem is plug in the value of x that you're approaching, see if it works. Well, if you put that 3 on bottom, you get 0. If you put the 3 on top, this is going to be the square root of 9, which is 3. 3 minus 3, you get another 0 on top. It's that indeterminate form again, which means the limit might still exist, you just have to do something else to find it. Now, normally, my next guess would be to factor, but I don't think there's any way you could factor the top or bottom of that fraction, so I'm running out of options. But we do have 2 new options today, and what I'm noticing on top here is the radical. So the method that I'm going to be using on this problem is the rationalizing radicals method. It was that first one that you wrote down on the last slide. Rationalize radicals. Now, what you wrote down earlier said you want to multiply by the conjugate on top and bottom. Let me explain that a little bit better now that we actually have it in front of us. When you go to find the conjugate, you're finding the conjugate of the part that has the radical. So this is square root of x plus 6 minus 3. The conjugate of that is going to be square root of x plus 6 plus 3. Remember, the conjugate just changes the sign in the middle. You don't change the sign under the square root. It just changes the sign in the middle. Now, whatever I do on top of the fraction, I also have to do on bottom. So I'm multiplying by the conjugate on top and bottom. Okie doke. Well, what I kind of like to do on top is sort of think of those as binomials. I know it's a little bit more complicated than our normal binomial, but technically, since all of that is under a square root, that is one term, that is one term. So there's a binomial being multiplied by another binomial. And how do we multiply binomials? We FOIL. Yeah, we FOIL. So that's what we're going to do on top. Now, there is a little shortcut to foiling conjugates. I'm not sure if you remember this or not, back from pre-calc and maybe even back to Algebra 2. When you FOIL conjugates, the O and the I of the foiling always drop out. So when I FOIL these, I'm only going to multiply the first terms and the last terms. You can do the O and the I if you want, but you don't have to because they're conjugates. So here goes nothing. I'm going to FOIL. Now, I'm starting with the first terms. I don't know if you remember this or not either, but I told you a long time ago, the square root of something times the square root of the same something just equals that something. It's not under a square root anymore, but the square root of something times the square root of the same something is just that something. And why I'm telling you that is because we're taking square root of x plus 6 times another square root of x plus 6. So that is just going to be x plus 6. Square root of x plus 6 times another square root of x plus 6 is x plus 6. Now again, you don't have to do the outer or the inner. If you did, it would end up being 3 square root of x plus 6 minus 3 square root of x plus 6. And that just drops out. So let me just get to the last terms. Negative 3 times positive 3, that is negative 9. So right now, on top here, I'm actually going to put this on the bottom where there's a little bit more room. I've got just x plus 6 minus 9. I FOILed out those binomials on the top. Now, when you do the bottom, here's kind of a nice little shortcut for you. This is another binomial times a binomial, but it's actually going to be helpful later on if you don't FOIL on bottom. You'll see why here in a minute. You got to trust me. But I'm just going to leave the bottom as x minus 3 times the quantity square root of x plus 6 plus 3. FOIL on top. Don't worry about FOILing on bottom because I'll show you here in 2 seconds why it's going to work out nicer if you don't. Now we can probably make, bless you, we can probably make that look better. 6 minus 9 is negative 3. So all I did from here to here was simplify the numerator. Now it's just x minus 3. And now do you happen to see why I didn't FOIL the bottom? What's going to happen? Yes, the x minus 3's are going to drop off. Now you do still have to put a little 1 on top just to hold that place. We had that happen a little bit yesterday. But now I'm taking the limit as x approaches 3 of 1 over the square root of x plus 6 plus 3. Now that we've done all of that work, we're going to cross our fingers and we're going to try direct substitution again. And we're going to hope that it actually works this time. So put a 3 right there for x. It's going to look like this. 1 over square root of 3 plus 6 plus 3. If you keep going with that, this is going to end up being the square root of 9. And the square root of 9 is 3. So on bottom, you're just taking 3 plus 3, which is 6. So 1/6 is the limit of that function, kind of a messy one, as x approaches 3. Okay, rationalizing radicals. The steps that we just did there, all the time, anytime you rationalize radicals, a lot of that stuff should be the same. I mean, you'll have different numbers up here, but you always want to FOIL the top, not the bottom. And you should always have something simplify or cross out like we did. And then at that point, you can go back and plug in the x. It's complicated at first, but it's kind of nice because, like I said, they all pretty much work the same way. A lot of those steps are the same. Any questions on that one? Good stuff there. Rationalizing radicals. Let's keep going. Example 2, we're finding the limit as x approaches 2 of 2 minus x all over x squared minus 4. All right, we can't forget about our other methods. First thing you should always try is plug in that value for x. It's not going to work. You're going to get 0 on top, 0 on bottom. So direct substitution's not working right now. The next thing you should look for is factoring, because that's a lot easier than going through what we just did on the last problem. So factoring, I do notice the part on bottom is a difference of squares. So let me just kind of recopy everything else for right now. The 2 minus x I'm going to leave alone for a minute. And a difference of squares is going to end up being x plus 2 times x minus 2. Well, I'm close to where I need to be, but 2 minus x is not the same as x minus 2. You can't switch things around a minus sign. You could with a plus sign. 2 plus x, x plus 2, that's the same. But subtraction is not commutative. So I'm going to show you a little trick that you can do on top, or I guess you could do it on bottom, but I'm going to do it on top to show you how to change 2 minus x to be x minus 2. It's not the same thing, but we could pull a -1 out of both of those terms. Let me show you what that's going to do. If I factor out a -1, 2 divided by -1 is -2, and -x divided by -1, that is positive x. So if you see what I'm doing here, -2 plus x, that's the same if you switch that around, because you can now, it's a plus. If you switch that around, it would say x minus 2. So the main idea here is that if you pull out a -1, you can flip those two terms around the minus sign. I showed you how it looked technically with the -2 plus x, but you don't really have to write it like that. Once you see how it works, it's the same as x minus 2. Okay, well I feel a lot better now because the x minus 2's can drop out. Now I'm just taking the limit as x approaches 2 of -1 over x plus 2. So we can finally plug in that value of x. So you'll have -1 over 2 plus 2, or -1 over 4. You can keep the negative on top or out front, doesn't matter. Okay, any questions about that one? That was like one of our methods from yesterday, but just something a little bit new there on top. Now, I'm going to try just one more example with you, and it's a good one. Number 3, we're finding the limit as x approaches 0 of 1 over 2 plus x minus 1/2 all over x. Oh boy, we got a lot going on up there. You know, I guess you could try direct substitution first, but you're going to get a 0 on bottom. If you put it in right here, that fraction would just end up being 1 over 2. So 1/2 minus 1/2, that's also going to give you a 0 on top. So thinking about our other methods, this is definitely a complex fraction. You have fractions in a fraction. So I'm going to have to approach this using that last method that we wrote down at the beginning of class. We're going to simplify complex fractions. Now, when we do this, what you wrote down earlier said we're going to multiply the top and bottom by the LCD of the fractions. And the fractions that I'm talking about are these fractions on top. We need to figure out, and I kind of like to put parentheses around that just since it's a binomial, we have to figure out what the LCD is of 1 over 2 plus x and 1 over 2. Now, normally with an LCD, you try to kind of make them the same thing. But, you know, for example, if you had 1/5 plus 1/2, if you were trying to add those fractions up and you were trying to get the LCD, 5 and 2, I mean, there's nothing smaller than 10 that they go into. To get the LCD right here, we had to take 5 times 2 because there's nothing else that they go into. It's the same idea up here. I can't get 2 to turn into a 2 plus x. Or if you think of it the other way, I can't get a 2 plus x to turn into 2. There's nothing else that they both go into. So to get the LCD in this problem, we're going to do like what we did down here. We're going to have to take that first denominator times the second denominator. Now for us, that's going to be 2 plus x, the first denominator, times 2. Now usually when we have a single term like that, we just kind of put it out front. It's not wrong if you leave it back here, but usually again with a single number times a quantity, you stick it out front. Okay, so this 2 times 2 plus x, that is what we have to multiply by on top and on bottom. It said start by multiplying by the LCD of the fractions on top and bottom. Now we're going to have to be careful about how we do this. I like, and I'm big on parentheses I guess, but I kind of like to think of that numerator as a quantity. It's actually like another binomial. And technically, this is just a single term. I know you see the plus right there and it looks like two different things, but since the 2 is being multiplied by the 2 plus x, that's technically just one term. And so if you have one term times a binomial, you're going to have to distribute that one term to both of those terms in the binomial. So I'm taking 2 times 2 plus x times this fraction and times that fraction. Getting pretty complicated here, so hang with me. Now when I do that, on top, I'm just going to keep that limit part out front because I'm not really doing much with that yet. When I distribute to this fraction, I guess since this is a fraction right here, you could always think of that over 1 if you wanted to. So this fraction times that fraction, you can just multiply across the top and across the bottom. So it's going to turn into 2 times 2 plus x all over 2 plus x times 1. That's just 2 plus x. So again, what I have up here right now is just what I got once I distributed to the first fraction. Now let's do that again with the second fraction. Okay, 1 times 2 plus x, that would just be 2 times 2 plus x. All over on bottom, it's like taking 2 times 1, which is 2. Now I'm going to come back to that part here in a second. If you go ahead and do the bottom, all you're doing on bottom is taking x times 2 plus x. I may just take the x times the 2 and write it as 2x times 2 plus x. I'm not really going to worry about distributing the 2x right now because probably like what happened on the last complicated limit problem, number 1, you'll end up getting something to cross out.
Would it not be easier if you took distributed your LCD like -4 plus 2x?
You can, but the next step up here is going to be to start crossing stuff out. So yeah, I would probably just leave it with the 2's because that is going to be the next thing that happens. Let me catch up here to the PowerPoint. So I just gave it away, but here we go. 2 plus x, 2 plus x, those are going to drop off. And then on the other fraction, there's a 2 on top and bottom. So those drop off. Now, if you look at what you have left over, I'm not really doing much to the bottom right now. If you just look at the top, the only thing that you have over here is a 2. So I've got the 2 there, and I've got the minus sign to go with it. But be careful, because what you have on this side is a quantity that really needs to stick together. You're going to end up distributing that minus here in just a second. So if you want to go ahead and do that, you can. I'm just going to leave it like that. And then denominator, still just 2x times 2 plus x. Okay, here comes the distributing. I'm just distributing a minus on top. Now it says the limit as x approaches 0 of 2 minus 2 minus x all over 2x times 2 plus x. All right, let's keep going with this. 2 minus 2, you maybe spotted that already. Those are going to drop off. So now on top, you just have negative x. All right, we're doing a lot of simplifying here. Is there anything else you could simplify on top and bottom? See anything on top that you also have on bottom? Yeah, you also have x's there that could simplify and drop off. Now, you would still need a negative 1 on top to take care of that. And it's all over 2 times 2 plus x. The x out front is gone now, so just 2 times 2 plus x. And finally, we should be able to plug in that 0. Okay, so now this is going to say on bottom 2 times 2 plus 0. Well, 2 plus 0 is 2, and 2 times 2, that is going to end up being a 4. So negative 1/4. That's actually the same answer that we got on example 2 today. But that one obviously much different because of the complex fractions. Now, I realize that is a lot of work there, maybe a little foggy still, but you can count on the same steps when you get to these in your homework. You're always taking the top and bottom times the LCD of those. You're always going to take that times that. And then again, a lot of the other stuff that crosses out should be the same. All right. I'm going to go ahead and give you C19. These are the correct problems today. From page 84 to 85, let's do 52 to 62 even. And it looks like there are some factoring problems at the beginning. So some of it might be factoring, others might have the radicals or the complex fractions.